Okay, so this is section 4.3. We've already done part of 4.1. Now we're skipping to 4.3 in the book. This is right triangle trigonometry, where you guys have SOHCATOA. You have this is right triangle trigonometry, so this only works with right triangles. You've got your sine, your cosine, your tangent, and we remember sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we remember that by saying SOHCATOA. That's how we remember it. From here, we also have the reciprocal trigonometric ratios. Cosecant, secant, and cotangent. So you do have to remember these. But I remember them because they are reciprocals of their friend, their partner here. They're reciprocals. So if I can remember SOHCATOA, then I can find cosecant, secant, and cotangent. The biggest mistake that I see students make with these is forgetting which one goes with sine and which one goes with cosine. Everybody knows that cotangent and tangent go together. Everybody figures that one out. It's these two people mix up. So I have a little trick to try to help you. Cosecant and secant. For each pair, for each partnership up here, there's only one co per partners. There's only one co per partners. So we have sine and cosecant. We have cosine and secant. We have tangent and cotangent. So there's only one CO per partners. All right, so if you put cosine with cosecant, you will be wrong. Got to have one co and one not co. Do you understand what I'm saying? CO, co? Okay. When we find the values of the 6 trigonometric ratios, trigonometric functions of theta, first of all, theta, I used it before, but just to go over that again, theta, T-H-E-T-A, is a Greek letter that we always use to represent the angle we're speaking of. So the theta is just representing that angle that I'm talking about right now. And this is asking me to find the 6 trigonometric functions of that particular theta. I will always put them in the same order so I remember them, so I'm memorizing them. And you have to, when you write sine, you have to put sine of theta. You see how it has theta up here? That theta, being after the word sine, does not get separated. This is one whole thing. Sine is not a thing by itself. The sine of theta is a thing by itself. It has to be together. Otherwise, you're going to mess up later. So sine of theta is equal to, and that's the opposite over the hypotenuse. So we have the opposite, which is 3. And what is my hypotenuse? Oh my gosh. How'd you know it was 5? What's 3, 4, 5 mean? Oh. It is a Pythagorean triple, and if you know your triples, you're going to save yourself a lot of time in here. You can make a note off to the side. Here's some common triples. Also, these triples are used all the time on your ACT. So if you know them, and you know the ACT is a time test, if you know them, that'll save you a lot of time. So common triples that are used are 3, 4, 5. And when I say 3, 4, 5, that could also be 3, 4, 5 with any scalar. So 6, 8, 10, 30, 40, 50. You multiply all those numbers by the same number, and it is a 3, 4, 5 common triple. 5, 12, 13. 8, 15, 17. I know a couple more. Do you guys know any others? Which one is that, Amelia? 7, 24, 25. There's another one, but I can't remember right now. These are the ones that I normally see in the book. So there's like 4 of them minimal that you should know to save you a lot of time. Okay. So we know this is 5. Otherwise, if I did not know it was 5, what if it wasn't a triple? What if this was 2, 3? It would not be 4. What if it wasn't a triple? What would you have to do? Amelia? Yeah, if it's not a triple, you will have to use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for your missing side. Or if you didn't realize it's a triple, extra work for you. All right, going back to this. Sine theta is 3 over 5. Cosine theta is the adjacent, which is the one touching it, but not the hypotenuse, 4 over 5. And tangent theta is 3 over 4. So those are the ones I know by SOHCATOA. Then we do our cosecant, our secant, and our cotangent. So to get these 3, I just flip my first 3. That's how I do it. So I get the first 3 and then flip the second 3. Okay, really fast. If this had not been 3, 4, 5, if it had been 3 radical 7, 4 radical 7, and 5 radical 7, if it had been that instead, and we did our sine and we got 3 radical 7 over 4 radical 7, what would I have to do? So not rationalize, because before I give myself more work, I'm going to see if something simplifies. Does anything simplify? If they're both radicals and they're exactly the same number, we can reduce them. We can cancel this out. And, oops, that was supposed to be a 5, not a 4. Sorry. You can reduce them and they'll cancel out and it'll still give you 3/5 as your answer. So the reason why I put this in here is you should be reducing and writing all your answers in simplest form. Now, Neil, what you said about rationalizing, if it did need to be rationalized, then I would do it. For sure. Because that would be simplest form. So let's write a note here, because we're actually about to do it, I believe. We'll write simplify and rationalize. Simplify and rationalize. So the next one says the cosecant of theta is 2. So I like a picture. You don't have to use a picture, but I feel like it helps me. I'm a visual person. So I'm going to draw a picture. Where my theta goes does not matter. What matters is just that I put my 3 and my 2 in the correct place according to that theta. I'm going to have to find the other trigonometric ratios, so I'm just going to write all of them down. Oops. Starting with sine. And we're going to be doing this stuff for like 3 months. Knowing these 6 is helpful. Just, 3 months. Don't be lazy now. Okay, what was given to me is that the cosecant is 3 over 2. So without even drawing the picture, can you find a different answer over here? What can you find, Mike? Sine is what? 2 over 3. Is opposite over hypotenuse. So now I'm going to go over here and I'm going to say the opposite of theta has to be, and the hypotenuse has to be 3. Is 2 a triple? No, 3, 4, 5 is like the smallest one. So we'll have to do Pythagorean theorem. We'll go 2 squared plus b squared equals 3 squared. And I get, whoop, I went off the screen a little bit. I get b is square root of 5. So my cosine is square root of 5 over hypotenuse 3. And then my tangent is 2 over square root 5. Can I leave 2 over square root 5? No, that's the kind we have to rationalize. So we're going to multiply by square root of 5 over square root of 5. It's going to give me 2 square root 5 over 5. And then can the 5... Why not, Sammy? Say it again. I didn't hear. This is a radical. They're not both radicals. Or they're both not. They both have to be the same to be able to reduce it. So then that would be the tangent. All right, secant. Secant, I just have to flip the cosine. So I'm going to flip 3 over square root 5. Is that the secant? Not quite. What do we have to do? Rationalize. You have to multiply the top and the bottom by square root 5 over square root 5. You're multiplying by a value of 1. I get 3 square root 5 over 5. Done. Notice I haven't used my calculator once. Cotangent is just flipping the tangent. I'm going to give you a word of advice. If I had to rationalize here, don't flip the rationalized one. Go back and flip the original one because you'll have less work to do. So if I flip this one here and do radical 5 over 2, I don't have to rationalize. If I flip this one, I would have to rationalize and reduce and then eventually get the same answer. All right, the last thing that we're doing today, 6 trigonometric ratios of 45 degrees, 30 degrees, and 60 degrees. 3 side lengths. These could be the 3 side lengths. They could be multiplied by any scalar, so this could be like 5, 5, 5, square root 2. But we've already done this stuff, and we've already written the sine, cosine, and tangent in that one assignment. So I'm going to have you take a moment, and I want you to write the sine, all six trigonometric ratios for 45, all 6 trigonometric ratios for 30, and all 6 trigonometric ratios for 60. Bless you. Let's see. Oh my gosh. I only make mistakes up here when I use my pen that doesn't erase. That's the only time I make mistakes. Okay, so you guys are going to go through, and we're going to do our SOHCATOA. Sine of 45 degrees should be radical 2 over 2. Cosine of 45 degrees is the exact same answer. Tangent of 45 degrees is 1 because you're putting 1 over 1, which is 1. Cosecant, I'm going to flip radical 2 over 2. And when I flip it, I'll just do it off to the side here. When I flip it, I have to rationalize, which gives me 2 radical 2 over 2, and then those 2's cancel, and we just get radical 2. Secant is the exact same thing as cosecant, because cosine and sine are the same, so radical 2. And then we flip 1 and we get 1 for tangent. So one thing about memorizing these is you won't have to keep rationalizing every time you flip them if you know what they are. Okay? And remember I was talking about on Friday, I was talking about how the 45, where it only has 2 different sides, is the one with the radical 2. So the only radical 2's down here in any of these 3 special right triangles, the only radical 2's are going to be in the 45's. You'll have no radical 2 in any of these. Any radicals that are in any of these are going to be which one? Radical 3, because this one has 3 different sides. Since it has 3 different sides, that's the one that has the radical 3 in it. Just for a trick to help you remember. Okay, so sine of 30 is a half. Cosine of 30 is radical 3 over 2. And tangent of 30 is the one with all the 3's in it. It's radical 3 over 3. The tangent of 30 is the one with all the 3's in it. It's radical 3 over 3. Saying silly things that I say to myself to help me remember. Because I'm not doing these right now. I'm remembering them. Cosecant 30 is 2. Secant of 30, when I flip this one, I have to rationalize it, and I get 2 radical 3 over 3. So that one has 3's in it. And then the cotangent of 30 degrees, I flip radical 3 over 3, and it ends up giving me radical 3. The sine of 60 is radical 3 over 2. And the cosine of 60 is 1/2. Things that you will notice when you have these memorized, if you have these memorized, when you have them memorized, is that these are the same. Tangent of 60 is radical 3, which is the same as cotangent of 30. Cosecant is 2 radical 3 over 3. Secant is 2. These are the same. And then cotangent of 60 is radical 3 over 3, which is the same as the tangent of 30. So like these all repeat themselves just in different places. So our assignment today, I have posted on Canvas. So I'm going to open it on Canvas here real fast because I didn't write it down anywhere. Posted it on Canvas. It's in the book. I have linked to the book. And then if you want to check out a book today, you didn't have it over the weekend, you decided, yeah, I'm ready, I want to check out a book, then I will do book checkouts too. Otherwise, you guys have 20 minutes to work on it. They don't have it for pre-calc.